Hello everybody. Today we can study more about capacitance and parallel plate capacitor. Last day we discussed about what is a capacitor and what is the equation for finding the capacitance. We also discussed about the effect of a dielectric medium present inside of a capacitor. Today we shall study more about it. Okay, before going to our topic, I want to remind you one thing. The symbol for a capacitor will be like this. This is the two terminals. These are the two terminals. Okay, and in case of a cell, it will be like this. One terminal will be lengthier one, another one will be less. So this is the difference between a capacitor and a cell, its symbol. Thus you should be more careful while you are drawing the symbols. Okay, now let us study about a parallel plate capacitor. Today we shall discuss about the total electric field inside of a capacitor. Last time we discussed while we are giving an electricity to the two plates of the capacitor, there will be produced an electric field from the positive plate to the negative plate. What is the value of that electric field? We shall calculate it today. For that, you should remember what we studied in the first chapter about electric field. Okay, in page 38, in the first chapter, we discussed about the electric field due to a uniformly charged infinitely plane sheet. There, the electric field at any point 1 or 2 here. How much will be that? It is E is equal to sigma by 2 epsilon 0. Sigma is the charge density. This is the sheet. It has uniformly charged and infinite plane sheet. So all this surface, this sheet contains some charge. The total charge Q divided by the total area, that is known as surface charge density sigma. Sigma is equal to Q divided by A. In that case, electric field is equal to sigma by 2 epsilon 0. That equation can be used here. Instead of one plate, in case of a parallel plate capacitor, we have two plates. At any region, there will be electric field because of the positively charged plate and the negatively charged plate. Thus, there is a region 1. You can see here, this region 1 is a space outside of a capacitor. The region 2 is also a space that is outside of the capacitor. This is the inner region of the capacitor. We shall study the electric field because of the parallel plate capacitor in these three regions. Okay, so we shall draw it again. Here one plate and another plate. One is positively charged. Another one is negatively charged. And this is one region. Let it be 1. What will be the electric field at this region? Okay. So the distance is not important in the first chapter itself. Q by epsilon 0. The distance of the point that we are considering from the sheet or from the plate is not important. Only charge density is important. And charge density is sigma is equal to Q by A. A is the surface charge present in this plate. So the area of the capacitor is important. Compared to the area of the capacitor, the distance towards the capacitor will be very less. Therefore, compared to the distance towards this point, as the area of the capacitor is high, we may imagine that the capacitor plate has an infinite area. In reality, the capacitor plate has only a definite shape, but compared to the distance towards the point that we are comparing, the area of the capacitor plate is very large. Therefore, we may imagine that the plates have an infinite area, infinite size. That's why we can make use of the equation that we studied in the first chapter. Electric field at this point is equal to sigma by 2 epsilon 0 because of one plate. But here there are 2 plates. Okay. At this point, there will be an electric field because of the positively charged plate and negatively charged plate. The direction of the electric field because of the positively charged plate is radially outward. And direction of the electric field at the point because of the negatively charged plate is radially inwards. We already studied. And the magnitude is same because the distance is not important, because the electric field E is equal to sigma by 2 epsilon 0. Sigma by 2 epsilon 0. Then the electric field because of the positively charged plate will be sigma by 2 epsilon 0. You can see this equation, sigma by 2 epsilon 0, and because of the negatively charged plate is minus sigma by 2 epsilon 0. While you are adding, you will get electric field will be 0. In the same way, in this outer region, there also there will be electric field because of the negatively charged plate, that is radially inwards. Electric field because of the positively charged plate, radially outward. Okay. While we are adding them, we will get 0. Because electric field is equal to sigma by 2 epsilon 0 because of the positively charged plate plus minus sigma by 2 epsilon 0 because of the negatively charged plate. As a result, we will get 0. Okay. That means electric field outside of a parallel plate capacitor will be 0. Whatever be the charge present in the capacitor plate, electric field outside of the capacitor will be 0. Okay. Now we shall discuss what will happen to the electric field inside of a capacitor. This is one plate. This is the second plate. Here the electric field, because of the positive charge, radially outward, means against to the positive charge. Electric field, because of the negatively charged plate, is radially inwards. See, both are in the same direction. Thus, the total electric field inside of the capacitor, electric field because of the positively charged plate, electric field because of the negatively charged plate, all are in the same direction. So we can add E is equal to sigma by 2 epsilon 0 plus sigma by 2 epsilon 0. As a result, we will get E is equal to sigma by epsilon 0. This is the equation for finding the electric field inside of a capacitor. As I always mentioned to you, we should always compare the properties of a capacitor with that of a current carrying solenoid. Like that we are studying throughout the chapters. The properties are similar. Electric field will be produced by a capacitor. Meantime, solenoid will produce magnetic field. We will study about solenoid in the upcoming chapters. However, in the lower class you already studied about a current carrying solenoid. Inside of a current carrying solenoid, magnetic field lines are parallel to each other and equally spaced. And if you are drawing the magnetic field outside of it, they are not parallel, they are curved. And see, just outside of the solenoid, magnetic field is 0. In the same way, in case of a parallel plate capacitor, electric field outside will be 0 and electric field inside is equal to sigma by epsilon 0. There is no factor related with the position. That means at anywhere inside of the parallel plate capacitor, electric field will be same. That means electric field is uniform. Thus we can represent the electric field lines are parallel to each other and equally spaced. Okay, this we studied here. Electric field E is equal to sigma by epsilon 0. But E is equal to sigma by epsilon 0, but sigma is equal to Q by A. Therefore, E is equal to Q by A into epsilon 0. Now, we shall discuss about the relation between electric field and potential. We have already studied in the last class. E is equal to V divided by D. Here, D is the separation between those two parallel plates. Therefore, V is equal to E into D. Now we shall substitute the value of E here, that is Q by A into epsilon 0 into D, that is QD divided by A epsilon 0. Okay. Therefore, what can we say? From here we can make the equation for Q divided by V. Here V is equal to Q D divided by A into epsilon 0. We shall take V to the other side. We will get Q by V, and all other terms can go to the left side. Then we will get A epsilon 0 D. A will go to the upper side, epsilon 0 will go to the upper side, and D will come down. Okay. Then we will get A epsilon 0 divided by D is equal to Q divided by V. But we already studied in the last class, Q by V is known as C. Therefore, we got an equation for capacitance. C is equal to A epsilon 0 divided by D. This you can see here. Last day we studied an equation for the capacitance of a capacitor. C is equal to Q by V. Now we got an equation epsilon 0 A divided by D. We already know what is epsilon 0. It is permittivity of free space. Is a factor related with the space in between the parallel plate. We shall discuss just after this about it. Okay. And A is the area of the capacitor plate. D is the separation between the capacitor plate. What does it mean? Capacitance of a capacitor only related with the geometrical factors of the capacitor. Capacitance of a capacitor only related with the geometrical factors related with it, not any other factors. This can be asked in the examination. Prove that capacitance of a capacitor only related with the geometrical factors. Then you can start with the equation for the electric field inside of a capacitor. E is equal to sigma by epsilon 0. Then sigma is equal to Q by A, therefore Q by epsilon 0 A. But the relation between potential difference and electric field, V is equal to E into D. That is, E is equal to Q by A into epsilon 0. Q by epsilon 0 A into D. Thus, but this Q divided by this V, C is equal to Q by V is equal to epsilon 0 A into D. In this way we can verify that capacitance of a capacitor only depends upon the geometrical factors. As I mentioned, the same thing will be applicable in case of a solenoid. In case of a current carrying solenoid, the inductance, in case of a capacitor it will be capacitance. In the same way, in case of a solenoid it will be inductance. Inductance of a solenoid or an inductor also depends only on its geometrical factors. You don't want to study it now, we will study in some other chapter. But I just told you the same comparison will be there. In case of a capacitor, its capacitance only depends on the geometrical factors. As in the same way, in case of an inductor or a current carrying solenoid, inductance will be depending only on its geometrical factors. Okay, now we shall give some values for it. The values for finding the capacitance as a practice that is given in the textbook. Epsilon 0 8.85 into 10 raised to minus 12. A. Area of the capacitor. Let area of the capacitor is 1 meter square. D. D is the separation between the capacitor. It is taken as 10 raised to minus 3 meter. 10 raised to minus 3 meter means 1 millimeter. Thus, the plates of the capacitor separated by only a distance 1 millimeter. Then we will get capacitance is 8.85 into 10 raised to minus 9 farad. 10 raised to minus 9 farad means a very small value. We already studied yesterday. 10 raised to minus 9 farad means nanofarad. Means that value is too small. See, here we have taken the area of the capacitor plate is 1 meter square. When will you are getting 1 meter square area? You want to take a sheet, metallic sheet of 1 meter length and 1 meter breadth. That is actually not practical. In reality, we cannot make such a capacitor. Actually, the size of the capacitor is too small. Even if we have taken a capacitor with an area 1 meter square, the capacitance is too small. As per this equation, the capacitance can increase when the area of the plate of the capacitor increases and the separation between them will decrease. We have minimized the separation is only with 1 millimeter. The plates are present very close to each other for increasing the capacitance. Similarly, area of the capacitor plate also made very large. So these things are not really practical, but for you to understand, we have given this value. Even in this situation, even we have taken the values for the area of the capacitance very large and the separation very small, we got a very small value for the capacitance. That's why I already told you farad is a large unit. As farad a large unit, we got the capacitance as a small value. Okay. Again, for you to understand, we may do another method. Suppose I want to make a capacitor with a 1 farad capacitance. Okay, that is given here. 1 farad means 1 coulomb per volt. What should be the area of the plates of the capacitor? Here we have taken the separation between them is 1 centimeter. In the previous case, we have taken the separation is 1 millimeter. Here we have taken 1 centimeter. Okay. We have an equation C is equal to epsilon 0 A divided by D. By rearranging, we will get A is equal to C into D divided by epsilon 0. Substitute the values. C is capacitance, that is 1 farad. D is a separation, that is 10 raised to minus 2. Epsilon 0 8.85 into 10 raised to minus 12. What is the value we got? 10 raised to 9 meter square. 10 raised to 9 meter square means a very large value. Means for getting 1 farad capacitance, we needed to make a capacitor with a plate size about 30 kilometer length and breadth. That is not at all possible. What does it mean? All these things were given here just for you to understand. Farad is a very large unit. Therefore, we are not getting a capacitor with value 1 farad. We will get like a 100 microfarad, 100 picofarad, etc. Okay. Okay, now we shall study about the effect of a dielectric medium present inside of the capacitor plate. Actually, we have already studied about it. These things we already studied. Whenever we have kept a dielectric medium in between the parallel plate capacitor, they will align in different direction before the switch is inserted, because there is no external electric field. But after we are switching on, what happens? The capacitor plates will get some charge. As a result, there will produce an electric field inside of it. Because of the action of the external electric field, all the dipoles starts to align in the same direction. As a result, we will get a total dipole moment per unit volume. Okay, to discuss about the effect of the dielectric medium present inside of the parallel plate, we shall introduce new terms V0 and E0 as here. V0 means the potential difference voltage given to the plates of the capacitor in the absence of a dielectric medium. Up to this time we studied about the same electric field or the capacitance when no dielectric medium present inside of it. But as we are going to discuss about the effect of the dielectric medium, we are forced to represent both of the things with the two different symbols. E0 is the electric field when there is no dielectric medium. V is the potential present when there is a dielectric medium. V is the potential difference between the plates of the capacitor if a dielectric medium present inside of it. I think you understand the difference between V and V0, E and E0. Okay. So we shall write the equation V is equal to E into D. Last time we wrote V is equal to E into D. Here V0 is equal to E0 into D, if there is no dielectric medium present. And similarly, the equation for the capacitance, we already studied C is equal to Q by V, but here we are going to write C0 is equal to Q by V0, and that is epsilon 0 A divided by D. Okay. Now we can see a picture given in the page 73. This is the picture. We shall discuss about it. This is the picture. When an external electric field acting between the two parallel plates, these are the two parallel plates, like this. As a result, there will be an electric field E. Thus, what happened? Because of the action of the electric field, all the dipoles will align in the same direction. Positive pole will be attracted to the negatively charged plate. Negative pole of the dipole will attract toward the positive charged plate. Okay, so we got an alignment, thus it is polarized. We got a polarization, that means dipole moment per unit volume. What will happen eventually? You can see there are in charges, positive charge of one dipole, negative charge of another dipole. The effect of this positive charge and this negative charge will be cancelled. We can cancel that effect. This positive and negative charge effect will be cancelled. This positive and negative charge, like this, one positive charge and another negative charge, that effect cancelled. Similarly, this positive and negative, that effect cancelled. See, finally we will get charge only in the outer surface of the dipole medium. Okay, now you can consider there are two surfaces. One is the surface of the parallel plate capacitor, other one is the outer surface of the dielectric medium. Okay, sigma is the surface charge density of the parallel plate capacitor. Sigma P is the surface charge density of the dipole medium. P represents that surface charge is producing because of the polarization. Okay, as it is minus charge, it is minus sigma P. What is the total surface charge density in this setup? Surface charge density because of the positive charge plate and negatively charged dipole, that is sigma minus sigma P. Or in the other side, this will be minus sigma plus sigma P. Anyway, finally we can say, if there is no dielectric medium, the surface charge density is sigma. If there is a dielectric medium, the surface charge density became sigma minus sigma P. Okay, there will be a charge on the surface of the parallel plate, and just in touch with that parallel plate there is a dielectric medium, an insulator. Inner charge effects cancelled and there is an effect of charge on its surface. That surface charge density is sigma P. As a result, there is two surface charges. Surface charge of the plate, surface charge of the dielectric medium. The total surface charge density will be sigma minus sigma P. Thus, if there is no dielectric medium, we studied about the electric field. E is equal to sigma by epsilon 0, but here we need to write E0 is equal to sigma by epsilon 0, because E0 is the electric field if there is no dielectric medium. Thus, if there is no dielectric medium, E0 is equal to sigma by epsilon 0. And when a dielectric medium present, we want to write E. Instead of E0, we need to write E. And the sigma became sigma minus sigma, because surface charge density is the sum of the surface charge density of the plate and by the polarization. This is the equation we studied. V0 is equal to E0 into D if there is no dielectric medium. And when there is a dielectric medium, we could write V is equal to E into D. We shall substitute this value for electric field. Thus, sigma minus sigma P divided by epsilon 0 into D, that is V. Okay. Now, once again, if you are discussing, there is a relationship between the electric field and the surface charge density. See, if there is no external electric field, dipoles aligned in different direction, then individually dipoles have some dipole moment, but the total dipole moment will be 0. As a result, there is no sigma p also. Okay, but while we are increasing the charge of the plate, Q increasing, when Q increasing, sigma will increase, surface charge density of the plate will increase. When sigma increases, what will happen? When sigma increases, E also will increase, because E is equal to sigma by epsilon 0. Thus, when surface charge density of the plate increasing, electric field will increase. When electric field increasing, more and more dipoles starts to align in the same direction. They will start to be polarized. Thus, we will get a total dipole moment per unit volume. As a result, here we will get a surface charge density. That means sigma p will increase. I will say once more. When sigma increase, sigma means the charge density of the plate. Sigma increases, E will increase. When E increases, sigma p will increase. Therefore, already sigma increased and sigma p also will increase. Therefore, sigma minus sigma p also will increase. Once more, when sigma increase, E increase. When E increasing, polarization will increase. Polarization increasing, sigma p will increase. Thus, sigma increased, sigma p also increased. Therefore, sigma minus sigma p will increase. Thus, what can I say? When sigma increasing, E will increase. When E increases, sigma p will increase. When sigma p increases, sigma minus sigma p will increase. Okay, what does it mean? That means sigma minus sigma p is proportional to sigma. Because when sigma increases, E increases, E increasing, sigma p increases, sigma p increasing, sigma minus sigma p will increase. Thus I can say sigma minus sigma p is proportional to sigma. Or otherwise, I can say sigma minus sigma p is equal to a constant into sigma. That constant is 1 by k. You can see it here. Sigma minus sigma p is equal to sigma divided by k. Thus, in this equation 248, we can substitute. Instead of sigma minus sigma p, we can write sigma divided by k. Thus, V is equal to, instead of sigma minus sigma p, sigma by k. D is already here, epsilon is here. Thus, V is equal to sigma d divided by epsilon 0 into k. But sigma is equal to q by a. Therefore, qd divided by a epsilon 0 into k. Okay, is it clear? Then, this is V. Therefore, what is 1 by V? 1 by V is equal to a epsilon 0 k divided by qd. V is equal to qd divided by a epsilon 0 k. Therefore, 1 by V is equal to a epsilon 0 k divided by qd. Okay, 1 by V is this. So what is q into 1 by V? That means q by V. Q by V is equal to Q into A epsilon 0 K divided by QD. Okay. 1 by V is equal to A epsilon 0 K divided by QD. Therefore, if we are substituting Q here, that Q will be multiplied here. That Q and this Q will be cut. Therefore, what will we get? Q by V is equal to A epsilon 0 K divided by D. That Q by V is known as C. Thus, we can write C is equal to A epsilon 0 K divided by D. Again, instead of epsilon 0 K, we can write epsilon. You know what is epsilon 0? That is permittivity of free space. But now we are discussing about the effect of a dielectric medium. That means in between the parallel plate, now there is no free space. There is no vacant space. There is a dielectric medium. A dielectric medium may be air, plastic or paper or whatever it is. The permittivity of that medium is epsilon. Epsilon 0 is permittivity of free space. Permittivity of the dielectric medium is epsilon. That means if we are multiplying permittivity of free space with this constant K, we will get permittivity of that medium. This constant K is known as dielectric constant. We may write K is equal to epsilon divided by epsilon 0. Thus, K can called as dielectric constant, and sometimes we may call it as relative permittivity. Relative permittivity. What is relative permittivity? Permittivity of the medium divided by permittivity of free space. Like in small class we studied about relative density. Relative density means density of an object divided by density of water. The same way, relative permittivity is permittivity of the medium divided by permittivity of free space. Sometimes in some other chapter or some other textbook, this is also represented as epsilon R. Epsilon R means relative permittivity is epsilon divided by epsilon 0. Whenever there is no dielectric medium, if there is only free space, that is only theoretical factor. Whenever we are keeping two parallel plates, if we are conducting this experiment in our earth, most often there can be some medium, at least some air can be present in between the parallel plates. And if there is some dielectric medium, including air, permittivity will become permittivity of that medium. Epsilon 0 means only a permittivity of free space. Okay. We already studied several equations. E is equal to 1 by 4 pi epsilon 0 q1 q2 by r square, such equations. Epsilon 0, that means all that electric field, electrostatic potential, everything that is happening in free space, in vacuum. But in reality, all these experiments while we are conducting in our earth, there is some medium, at least air will be there. Then we cannot write 1 by 4 pi epsilon 0. We have to write it as 1 by 4 pi epsilon. Epsilon means permittivity of that medium. Okay. Thus, if we are substituting, instead of epsilon 0 into K, we can write epsilon. Then our equation will become C is equal to epsilon A divided by D. what we studied in the previous case? Previous case we studied C is equal to epsilon 0 A divided by D. That is the equation for the capacitance of the capacitor. But this could be written as C0 if there is no dielectric medium. C0 means capacitance of the capacitor if there is no dielectric medium. This need to be written as C0. C0 is equal to epsilon 0 A divided by D. And if there is a dielectric medium, C is equal to epsilon A divided by D. I will mention once more. If there is no dielectric medium, C0 is equal to epsilon 0 A divided by D. And if there is a medium, C is equal to epsilon A divided by D. Okay. Thus, we may also written as K is equal to C by C0. Just above we studied K is equal to epsilon divided by epsilon 0. But we got two equations. Is it? We got two equations. C0 is equal to epsilon 0 A divided by D. C is equal to epsilon A divided by D. Thus, if we are doing C by C0, from this, if we are doing C by C0, D and D will cut, A and A will cut, we will get epsilon divided by epsilon 0. Thus, epsilon divided by epsilon 0 means C by C0, and that is equal to K. Thus, we got two equations for finding the dielectric constant or relative permittivity. What are the two equations? K is equal to epsilon by epsilon 0 or C by C0. Okay, this much for today. And if you have any doubt, you can ask in that comment box. Okay.